Across millennia, scattered among clay tablets, sacred scrolls, and whispered myths, humanity has preserved haunting tales of a celestial anomaly, a rogue planet, a cosmic saboteur whose rare appearance heralds disaster and upheaval. The Sumerians called it Nibiru, the planet of crossing. Egyptians feared it as the destroyer. Biblical texts knew it as the wormwood star. Are these merely the colorful myths of ancient peoples, or are they fragmented memories of an all-too-real cosmic threat? Modern science, once quick to dismiss such legends, is now forced to reconsider. In 2016, astronomers Konstantin Batygin and Mike Brown from Caltech presented mathematical evidence suggesting the existence of a massive planet at the far edge of our solar system, Planet 9. Their calculations describe a world 5 to 10 times the mass of Earth, on a highly elongated orbit that takes between 10,000 and 20,000 years to complete a single revolution around the Sun. Here's where ancient myth and modern astrophysics begin to blur. Sumerian cuneiform tablets, dating as far back as the 4th millennium BCE, contain astonishingly accurate astronomical data. They describe a solar system of 12 celestial bodies, including a mysterious 12th planet, Nibiru. How did ancient people know about Neptune, discovered only in 1846, or Pluto in 1930? Were they simply guessing, or did they remember something we've forgotten? One of the most controversial voices in this debate is researcher Zecharia Sitchin. He spent decades interpreting ancient Mesopotamian texts and proposed a radical theory that Nibiru is a habitable world with a sweeping elliptical orbit, home to an advanced race known as the Anunnaki, beings who once visited Earth. Mainstream academia has rejected Sitchin's translations, but the uncanny parallels between his claims and recent astronomical findings are hard to ignore. Let's focus on what the data tells us. Something is warping the orbits of distant objects in the Kuiper Belt, a vast icy region beyond Neptune. These objects behave as if being shepherded by a massive, unseen force. The dwarf planet Sedna, for example, follows a wildly unusual orbit that can't be explained by known gravitational influences. And then there's the Kuiper Cliff, an abrupt drop-off in the number of objects beyond 50 astronomical units. What's causing it? Something or someone. These anomalies have left astronomers scratching their heads and have fueled growing speculation that a massive, unseen planet is hiding in the dark outskirts of our solar system. Ancient texts from multiple civilizations describe apocalyptic upheavals linked to a celestial intruder. The Egyptian Ipuwer papyrus eerily recounts plagues and chaos. The river is blood, the earth turned upside down, days are shrouded in darkness. The Babylonian Epic of Era speaks of a time when the stars left their appointed paths. These aren't just poetic metaphors. They're historical shockwaves echoing from a forgotten trauma. So what happens if Nibiru, or Planet 9, makes its next approach? Even without a direct collision, the consequences could be catastrophic. Its gravity might tilt Earth's axis, triggering sudden climate shifts. It could awaken tectonic fault lines and stir dormant volcanoes. Disturbed asteroid belts might send deadly space rocks hurtling toward us. It could disrupt our magnetosphere, disabling electronics and satellites. But perhaps the most chilling aspect of this theory is the cycle. Sumerian texts suggest that Nibiru returns roughly every 3,600 years. If this is true, its last passage might have occurred around 1600 BCE. a time curiously aligned with the collapse of Bronze Age civilizations, a period marked by mass migrations, natural disasters, and inexplicable cultural decline. Was this coincidence or consequence? The clock might be ticking again. Today, the hunt for Planet 9 continues, using the world's most powerful telescopes and cutting-edge simulations. We stand on the edge of either confirming the greatest myth ever told, or revealing that ancient peoples tried, in the only language they had, to warn us. It may not bear the name Nibiru, it may not carry golden tablets or alien emissaries, but if it exists, its return will reshape everything we think we know about history, science, and our place in the cosmos. One thing is certain, our solar system is far from tamed. It harbors secrets in its coldest, darkest corners, riddles older than civilization itself. And perhaps, just perhaps, the old stories were never stories at all. Maybe they were prophecies. Maybe they were the echo of survivors. Maybe the star of change is already on its way.
Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper Belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from 2 special space surveys called IRAS and ACARI. These 2 looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both IRAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The two detections weren't in the same spot in both surveys, and the way they appeared in the Akari map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier, but of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper Belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper Belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be two unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, If it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, negative 375 degrees Fahrenheit. Its core would be made of iron, and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we used a powerful slingshot path around the Sun. Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune, with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot, so the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang, and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper Belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda, yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper Belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Yeah, sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. A mysterious space visitor has recently passed its closest approach to Earth, flying by at a distance of 64 million miles. It might be something totally natural and born on the outskirts of the solar system, or some unknown civilization could be examining us from above right at this moment. This new object looks a lot like another strange wanderer called 3I Atlas, and you'll understand why we say strange pretty soon. So, could both of them come from the same place outside our solar system? What we do know is that this new object is relatively close to us, in space terms of course, and scientists are now studying it closely. They first spotted it inside our solar system, and people are paying attention because it showed up not long after 3I Atlas passed near our Sun. On November 2, 2025, astronomer Gennady Borisov, the same person who discovered interstellar comet 2I Borisov in 2019, found this new object. It's now got its official name and is listed in NASA's and the Minor Planet Center's databases. C2025V1 has some unusual features. Its orbit is tilted 113 degrees, which means it's moving almost up and over the regular path that planets take. Even more bizarre, its orbital plane is almost at a right angle to the path of 3I Atlas. Plus, it doesn't have a clear comet tail, which is odd. Right now, its orbit has an eccentricity of 1.0095. And let me break it down in human language. If that number was well above 1, it would mean the object definitely came from outside the solar system. But because it's only just a bit above 1, the most likely explanation is that C2025V1 came from the Oort cloud. That's a giant faraway shell of icy objects that surrounds the solar system. Now scientists check this by basically rewinding the object's path, sending it all the way back to about 1000 AU. That's 1,000 times farther than the Earth is from the Sun. At that huge distance, the planets can't mess with its motion anymore. When they redo the orbit from that point, its eccentricity, the number that tells you if it's from outside the solar system, usually drops below 1, which means it's still part of our solar system. But at the same time, even a tiny push from Jupiter while passing by could make even a normal Oort cloud comet look like it has an eccentricity slightly above 1. And on top of that, small blasts of gas coming off the comet's surface can also change the numbers a little. So, to put it simply, it probably isn't interstellar. It just looks that way because of small pushes and gas bursts. C2025V1 is still exciting, even if it comes from the Oort cloud, because studying it gives us a chance to analyze the material from that distant region and learn how our solar system formed and evolved. Now let's get back to the mystery of 3I Atlas. Before anything else, let's explain what 3I Atlas actually is. It's most likely a comet, basically a huge, dirty snowball flying through space. You can't see it with your own eyes or with a regular telescope. But there's good news. A powerful telescope in Italy is streaming it live for free. So anyone can actually watch this mysterious object as it passes by. Scientists think this comet weighs about 33 billion tons. That number is hard to imagine, so here are a few comparisons. The Eiffel Tower weighs around 10,000 tons. So 33 billion tons is the same as a whopping 3.3 million Eiffel Towers. And if you decide to compare the space visitor to buildings, 33 billion tons is about the same as the weight of several huge city areas made entirely of steel and concrete. But even all that size isn't the wildest part. Some experts think this object might be a piece of unknown technology from outside our galaxy. And they're not saying this just for fun. There are real reasons behind the theory. 3I Atlas was first noticed in July by NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS. Shortly after, NASA confirmed that the object wasn't from our solar system at all. It's an interstellar object, only the third ever discovered. The first one was Oumuamua in 2017, which looked long and flat and didn't behave like a normal rock. The second was Comet BI Borisov in 2019. Now we have 3I Atlas, and it is enormous compared with the other two. Its nucleus is up to 3.5 miles wide, while Oumuamua was only about a quarter mile long and Borisov was around a half-mile across. Besides being huge, 3I Atlas is unusual in several other ways. As it moves through the solar system, it's releasing massive amounts of carbon dioxide and gas. This suggests that 3I Atlas is 3 to 5 orders of magnitude, which means 1,000 to 100,000 times more massive than the other two known interstellar visitors. Such an enormous difference is a real scientific mystery. It's also traveling incredibly fast, about 150,000 miles per hour, which is almost 200 times the speed of sound. And unlike objects in our solar system, which followed curved paths because of gravity, 3I Atlas is moving on a nearly straight line. That alone makes it stand out. These odd behaviors have led some researchers to consider a pretty unexpected idea. 3I Atlas might be a probe sent by another civilization, possibly to study Earth. According to this theory, the object could be a sign of some kind of intelligence from beyond our solar system. Why do they think this? Well, because the object's movement doesn't match what you'd expect from something controlled only by gravity. It also passes close to Venus, Mars, and Jupiter, and these are the planets that might be especially interesting for an outside civilization to observe. Another very unusual feature of 3I Atlas's path is that its orbit is tilted only a little compared to the plane of the solar system, about 5 degrees, and it moves in the opposite direction to most planets. This feature might allow the object, or its creators, to take extremely precise measurements of planets, things like their orbits and sizes, to plan a perfect flight route through the solar system. And if 3I Atlas suddenly changes direction at some point, that could mean it's using a built-in engine instead of simply drifting through space. Now, new photos have also shown that 3I Atlas has at least 7 jets blasting material into space, some shooting in totally opposite directions. Now, if this thing is just a normal comet, it would have had to lose a huge amount of its original mass when it passed near the Sun, way more than just 10 to 20%. Only some of that material would actually push the object in one direction, so the total amount blown off would need to be massive. If that's what happened, then there should be now a giant cloud of gas and dust around 3I Atlas. And if that cloud exists, it'll be pretty easy to figure out what the comet is made of. The James Webb Space Telescope will check this when 3I Atlas gets closest to Earth on December 19, 2025. But if 3I Atlas is not a normal comet and is actually some kind of technology, it wouldn't need to lose that much material. Engines built by an advanced civilization could give it a boost while using way less gas because they shoot it out way faster. Faster exhaust gives more push with less fuel, so a technological object wouldn't need to blast away big chunks of itself the way a natural comet would. So, to sum it up, there's still a big mystery around 3I Atlas. Could it really be a technological mothership that released small probes into the inner solar system? But C2025 V1 doesn't fit that idea, unless one of the objects used some kind of engine. The closest their orbits ever come is about 46 million miles, and the two objects themselves were never closer to each other than about 140 million miles. The tiny non-gravitational push detected in 3I Atlas is nowhere near strong enough to close this gap. So, C2025 V1 is almost certainly not one of the many probes people imagine 3I Atlas might have released. A large space probe is nearing the Sun. The terrifying heat of the star begins to melt the shell of the spacecraft. Another moment, and the probe bursts into flames. In no time, it disintegrates in a powerful explosion. Ah, what a sad ending. If it were true, it was not a probe. It was a comet known as 3I Atlas. And despite everything people say, it's still intact and thriving. The thing is, there is a rumor online saying that comet 3I Atlas exploded when it got closest to the Sun. But astronomers say this is not true. There was no explosion. and the comet's nucleus still looks whole and undamaged, which is kinda surprising, since comets that pass very close to the Sun usually go through some serious changes. You see, comets are made of a mix of ice, dust, and rocky material, which is why they're often called dirty snowballs. So, when they come close to the Sun, the intense heat from our star makes their ice turn into gas. This new gas can burst out in huge jets, form a cloud around the comet called a coma, and/or be pushed away into a long tail. Sunlight makes all of these parts shine more brightly, and even people with small or simple telescopes can study the comet if the viewing conditions are good. But aside from being a breathtaking view, such a close approach can break off pieces of a comet or even tear its whole nucleus apart. Now, it's true that some comets survive this process, but many, especially small ones, or comets entering the inner solar system for the first time, break into pieces or disappear completely. Well, 3I Atlas acted differently. So there. It reached its closest point to the Sun on October 29, 2025. This point is called the perihelion. At that moment, the comet was about 130 million miles from the Sun. That's about 1.5 times the distance between the Sun and our planet. The comet was also on the opposite side of the Sun from Earth, so the star was blocking it from our view and we couldn't see the comet. Anyway, even though 3I Atlas could hypothetically break apart or release lots of fragments, it didn't. The nucleus stayed intact, and this made the comet's behavior even more unusual and interesting to scientists. They looked closely at the new photos and said everything looked normal. Now, interestingly, the day before, some people thought the comet had broken into pieces after it came out from behind the far side of the Sun. This idea became popular after a blog post said the comet had lost a lot of mass. So, to make this claim, the blog used photos taken on November 9th by 2 small telescopes in Spain. The pictures show jets of gas coming out of the comet. The scientists used this to estimate how much material was coming off the comet, claiming that it should have broken into at least 16 pieces. However, many scientists have questioned this statement. Most researchers say there's no proof that the comet exploded. One scientist who studies the comet says that all the images he had seen showed a completely normal, healthy comet. There's no sign that the main body of the comet has broken apart. Still, now that the comet is coming back into view, astronomers are watching it very carefully. They want to learn more about the comet's materials and structure. Right now, if you look at it from Earth, the comet seems to be slowly moving higher in the eastern sky. If the weather is good, people in many parts of the northern hemisphere can see it with a small telescope, like this one with a 6-inch lens. And many do pay attention to the comet. Since it was discovered in July, it has become the center of many curious ideas. Some people are sure that the comet, which comes from outside our solar system and might be more than 7 billion years old, could be a probe sent by a different civilization. Now, most astronomers strongly disagree, of course. They believe the comet is completely natural and comes from another star system somewhere in the Milky Way. And this is actually exciting. Comet 3I Atlas is only the 3rd interstellar comet ever seen, and it is the largest one of its kind. Before, it was Comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But 3I Atlas, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which was just a quarter-mile long, and Borisov, which is about 0.3 of a mile across. Plus, 3I Atlas may be the oldest comet humans have ever observed. Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. It was the first known object from another star system to pass through our solar system, basically our first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. As for 2I Borisov, it sits in between, at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma, a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the Sun. Plus, it also had a long tail of dust and gas. Now, 2I Borisov is speeding away from the Sun and will never return. But it allowed scientists to take a glimpse into the chemistry and history of distant worlds. Now, let's get back to Comet 3I Atlas. It will pass closest to Earth on December 19th. Until then, scientists will make many more observations. People will also make many new claims about the comet, that's for sure. But it's best to be cautious and not believe everything immediately. By the way, even though you can't see this famous comet with your own eyes or with a regular telescope, hey, that's good news. A powerful telescope in Italy is streaming it live for free. Whoa! So anyone can actually watch this mysterious object as it passes by. Scientists think this comet weighs about 33 billion tons. That's a big number. How about we make a few comparisons? The Eiffel Tower weighs around 10,000 tons. So, 33 billion tons is the same as 3.3 million Eiffel Towers. And if you decide to compare the space visitor to buildings, well, 33 billion tons is about the same as the weight of several huge city areas made entirely of steel and concrete. Now, 3I Atlas was first noticed in July by NASA's Asteroid Terrestrial Impact Last Alert System, which, if you're paying attention, is where they got the nickname Atlas. Shortly after, NASA confirmed that the object wasn't from our solar system at all. Now, besides being huge, 3I Atlas is unusual in several other ways. As it moves through the solar system, it's releasing massive amounts of carbon dioxide and dust. So this suggests that 3I Atlas is 3 to 5 orders of magnitude, which means 1,000 to 100,000 times more massive than the 2 other known interstellar visitors. Such an enormous difference is a real scientific mystery. It's also traveling incredibly fast, about 150,000 miles per hour, which is almost 200 times the speed of sound. Hey, that will get you a speeding ticket. And unlike objects in our solar system, which follow curved paths because of gravity, 3I Atlas is moving on a nearly straight line. That alone makes it stand out. Now that the comet has moved past the Sun, telescopes on Earth can see it again. Comet 3I Atlas is important to us because it's only the third interstellar visitor we've ever seen, and it may be the biggest and oldest one yet. And it didn't break apart near the Sun like some other comets. By studying it, scientists can learn what materials exist in other star systems and better understand how comets, and even planets, form in our galaxy.
Comet 3I Atlas crashes into Earth, and a wave of widespread destruction starts shaking our planet. Ginormous tsunamis are swallowing coastlines, devastating earthquakes are cracking the ground. Hot debris is igniting massive firestorms. Thick clouds of dust are blocking the sun. Now, that's what could happen if 3I Atlas, a massive comet traveling through the solar system, collided with our planet. But can this disaster actually occur? When will 3I Atlas be the closest to Earth? Let's figure this out. First of all, this comet turned out to be way larger than we previously thought. Its weight is likely a whopping 33 billion tons. Let's throw in a few comparisons to put it into perspective. The Eiffel Tower weighs about 10,000 tons. So, 33 billion tons is roughly the weight of 3.3 million Eiffel Towers. Impressive! Next, all the cars on Earth, and we're talking about 1.5 billion vehicles, each weighing about 1.5 tons, weigh approximately 2.25 billion tons. This means that the comet's mass is 15 times greater than the combined weight of literally all the cars on the planet. And finally, compared to buildings on Earth, 33 billion tons is equal to several large metropolitan areas made entirely of steel and concrete. But the whole idea of how big this comet is fades in comparison with an even crazier fact about it. It could be unknown technology from a different galaxy, and some experts are somewhat sure about that. But why? 3I Atlas was first spotted in July by NASA's Asteroid Terrestrial Impact Last Alert System. A bit later, the US Space Agency confirmed that the object was an interstellar object, only the third we have found so far. Before, it was Comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But the newest comet, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which is just a quarter-mile long, and Borisov, which is about 0.6 miles across. By the way, some believe that the comet could be even bigger, up to almost 7 miles, but scientists haven't found any proof of that yet. Besides its size, 3I Atlas is different in other ways too, which makes some scientists question its origins. The object is shedding huge amounts of carbon dioxide and dust while zooming towards the sun. It's most likely the proof that 3I Atlas is more massive than the other two interstellar objects by 3 to 5 orders of magnitude, which is basically a serious anomaly. The comet is also traveling toward the sun incredibly fast. We're talking about around 130,000 miles per hour, which is almost 170 times the speed of sound. Another weird thing is that this interstellar object is following a straight trajectory, unlike anything else in the solar system. Most space bodies move along curved orbits due to the force of gravity. That made some researchers believe that 3I Atlas might be a probe sent by another civilization to explore Earth, possibly with not-so-friendly intentions. Their theory is that the object could be a technological artifact, a sign of cosmic intelligence. You see, the comet moves in a pretty weird way that doesn't totally line up with just gravity. Its trajectory also takes it close to Venus, Mars, and Jupiter. And researchers think that these planets might be especially interesting for another civilization to pass by. Another bizarre fact, the space traveler also spins backward compared to most stuff in our solar system. This might be necessary to make it easier for 3I Atlas to get near Earth without much resistance. Some scientists think the comet's odd spin and flight path could help whoever or whatever made it take super precise measurements of the planets, things like their orbits and sizes, to plan a perfect route through the solar system. If 3I Atlas suddenly changes direction in a big way, that might mean it's using some kind of built-in engine instead of just drifting through space. There's also another theory that suggests it could be a piece of unknown tech that's still active. There's no need to worry though, at least at the moment. The comet isn't coming anywhere near us. NASA says it'll stay around 150 million miles from Earth when heading toward the sun. So the question is, where do such space visitors come from? Astronomers have found that the 3 interstellar objects we discovered came from totally different parts of the galaxy. And each of them has its own age and background. 3I Atlas turned out to be the oldest, about 4.6 billion years old, and it came from the Milky Way's thick disk. That's a region filled with older stars that have fewer heavy elements. 1I Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. Oumuamua, Hawaiian for a messenger from afar arriving first, was the first known object from another star system to pass through our solar system. Basically, the first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. It also sped up in a way that couldn't be explained by gravity alone. Changes in brightness showed it was tumbling end over end instead of spinning smoothly. At first, scientists were confused because the space body didn't have a tail or cloud of gas like a normal comet, even though it was accelerating. That led to a lot of debate about what it was made of and where it came from. Just like with 3I Atlas, some people wondered if it could be technology created by a space civilization. But most scientists now think Oumuamua was a totally natural object, just a really weird one. The best guess is that it was a comet releasing invisible hydrogen gas, which caused it to speed up slightly. Sadly, by the time astronomers found it, it was already heading out of the solar system, so there wasn't much time to study it. As for 2I Borisov, it sits in between at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. The comet was discovered in 2019 by Gennady Borisov, an amateur astronomer who actually built his own telescope to search for faint space objects. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma. That's a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the sun. Plus, it boasted a long tail of dust and gas. Studying 2I Borisov helped researchers learn more about how other planetary systems form. Observations showed that its dust grains were compact and that the amount of gases like carbon dioxide changed a lot as it approached the sun. It could mean that the comet formed under very different conditions than anything else in our solar system. Now, 2I Borisov is speeding away from the sun and will never return. But it allowed scientists to take a unique glimpse into the chemistry and history of distant worlds. Interestingly, the differences between these three space objects suggest that interstellar visitors have been getting kicked out of planetary systems all across the galaxy for billions of years, so it's not something new. To figure out if 3I Atlas might be some kind of probe from another planet, scientists are checking for any signs of technology, like strange radio signals, electric activity, and weird movement patterns. If the comet suddenly changes course or drops smaller objects nearby, it might be our cue. But even though 3I Atlas is moving in a pretty wild and energetic way, it's most likely just a natural interstellar object passing through. Researchers say they'll need a lot more proof before anyone can seriously say the space wanderer was sent by someone from another planet. What do you think about this newly discovered space traveler? Share your opinion in the comments.
So, we just spotted an asteroid so massive it could wipe out an entire continent if it ever hit Earth. And it's moving insanely fast, almost record speed. But what makes it really scary is how it's basically playing hide and seek with us. It can slip right into the sun's glare and vanish completely. And yeah, it just did it again. It disappeared. So when we finally spot it again, will we have enough time to prepare? Or could it already be too late for humanity? Yeah. Do I have your attention now? Ah, thanks. So meet 2025 SC79. That's a mouthful, so I'll just nickname it Scooby. This newly found asteroid is a sneaky one, the kind that loves hiding in the sun's glare. Think of it as trying to spot a firefly next to a stadium light. The brightness hits your eyes and outshines anything faint nearby. So yeah, you won't see that firefly. Now asteroids hide in the same frustrating way. When they end up close to the sun from our point of view on Earth, the glare overwhelms our telescopes, and the asteroid's dim, reflected light gets lost in it. That's why some asteroids can cruise along in the sun's direction and stay basically invisible to us. And scientists say the most dangerous asteroids, the ones that could wipe out a whole city, are the hardest to detect. That's why astronomers need to somehow dodge the sun's glare. One way they do it is by observing the sky during the short window of twilight. I mean, right before sunrise or just after sunset. And that timing is a big deal, because it's the only way to catch some risky asteroid before it sneaks up on Earth. Scientists say that if one of these so-called twilight asteroids ever gets close to Earth, it could be a serious impact threat. And it was during one of these twilight observing sessions that scientists finally spotted this huge asteroid. It was September 27, 2025. Scott Shepard, an astronomer at a Washington-based institute, was scanning the sky, hunting for anything unusual in our solar system. And he had an incredible tool in his hands, the Dark Energy Camera, or DECAM, one of the most powerful sky survey cameras on Earth, built to spot faint objects across huge areas of the universe. At one point, he spotted a faint dot moving across the image, so he quickly aimed the high-tech camera at it, and things got more interesting. Its movement matched what astronomers expect from asteroids that orbit very close to the Sun. Then, follow-up observations with the Gemini and Magellan telescopes confirmed the discovery. Yes, this really was an asteroid, and there are two particularly curious things about it. First, it's fast, like really fast. In fact, it is the second fastest known asteroid orbit in the solar system. It loops around the Sun once every 128 days. For comparison, Mercury, the closest planet to the Sun, takes 88 days to go around once. Second, its orbit is super rare. This is only the second known object that stays completely inside Venus's orbit. That also puts it in one of the rarest asteroid groups out there, the Atiras. These are asteroids whose orbits sit entirely inside Earth's orbit. Astronomers have found only a few of them so far, and Scooby is the 39th one in the list. The team of scientists also figured out that this asteroid is pretty big, measuring about 2,300 feet across. It's roughly the size of Merdeka 118, the second tallest building on Earth. If an asteroid this size ever slammed into Earth, it wouldn't just be bad, it would be catastrophic. We're talking about damage on a continental scale. It would blast a huge crater into the ground, then throw out a shockwave powerful enough to wipe out forests and wreck cities. Seismic waves would ripple through the crust, triggering widespread earthquakes around magnitude 7.4, and people could still feel them about 300 miles away from the strike. And that's not all. A brutal air pressure blast would race outward, shattering windows more than 1,000 miles away. Then comes the aftermath. Dust and debris from the impact could shoot up into the atmosphere, block some sunlight, and mess with our climate. I know, you might feel scared right now, but don't worry about it. Thankfully, Scooby isn't going to do anything like that, because it's not on a collision course with Earth. Right now, the math shows it won't be making any close passes by our planet, at least not anytime soon. Still, there's a lot more to learn about this asteroid, but any further studies will have to wait. For now, it has disappeared behind the Sun and is out of sight. Once it reappears, astronomers will take a closer look and try to learn more about what it's made of. That part really matters, because this asteroid is somehow holding up while orbiting so close to the Sun's brutal heat. You see, this asteroid gets very near to the Sun. At its closest point, this asteroid is blasted with almost 6 times Earth's sunlight. At that distance, its surface could heat up to about 440 degrees Fahrenheit. What scientists don't know yet is how a rock this big can get baked over and over again without falling apart. And there are 2 more things astronomers want to check once it comes back into view: how fast it spins and how bright it looks. Now, by bright, I mean how much sunlight it reflects, because asteroids don't make their own sunlight. They're just big rocky chunks that shine by reflecting sunlight back at us. Anyway, those clues can tell scientists what Scooby is made of. One possibility is that this asteroid is loaded with dense metal, and that could explain how it survives the Sun's brutal heat. And if that turns out to be true, this asteroid could be a relic from when the solar system was just forming. Or maybe it slowly moved closer to the Sun because the gravity of Venus and Mercury gently pulled on it again and again over millions of years. Now, even though SE-79 isn't a real danger to us, and there's still a lot we don't know about it, just finding it is already a big deal. It's a reminder that big asteroids can hide from us, So even in our own cosmic backyard, there are still blind spots where large objects can stay hidden until the right moment of twilight gives them away. And as our detection tech gets better, we keep finding more and more asteroids. By now, scientists have spotted over 1 million in the solar system. They come in all sizes, from monsters like Vesta that measure about 329 miles wide, all the way down to rocks that are smaller than a house. Now, out of all the asteroids we know, about 40,000 are what we call near-Earth asteroids, or NEAs. That just means their orbits bring them close to our neighborhood. Technically, their closest point to the Sun is less than 1.3 times the Earth-Sun distance. It's close enough for planetary defense systems to keep a careful eye on them. And that's exactly why we can relax. I mean, nobody has to lose sleep imagining an asteroid slamming into our planet. Every time scientists discover a new asteroid that comes anywhere near Earth, they track it and run the numbers right away. And then they map out its path years, decades, or even centuries into the future. And they don't do it by guesswork. NASA's automated systems, like Sentry, constantly scan the asteroid catalog and calculate whether any of these objects has even a small chance of hitting Earth over the next 100 years. If something looks risky, it jumps to the top of the watch list and gets followed up fast. So yeah, there are almost 2,000 near-Earth asteroids that technically have some chance of hitting us in the next 100 years. But don't panic. Most are small and harmless, hey, like me. And their odds of impact are usually way under 1%. See why I said we shouldn't stress too much? Cool. Now, sleep tight. Well, the space object 3I Atlas just whipped past the Sun, and instead of clearing things up, the new images made everything even stranger. Because if this thing really is a comet, then it's the strangest comet ever recorded. And if it's not a comet, then we're watching something completely new invade our solar system. So, should we be worried? This all started back in July 2025. Astronomers using the Atlas Survey Telescope in Chile spotted a faint, super fast-moving object, something unlike anything they'd seen before. That was our first look at 3I Atlas, and right away, scientists had a lot of questions. Where did it come from? What's it made of? But more importantly, what is this thing? At first glance, it almost looks like a tiny cell, right? Like something you'd see under a microscope, with a bright center like a nucleus, and this fuzzy outer layer. But when we look at it from a different angle, the mystery clears up. That glow is actually a comet tail. It's precisely because it looks like and behaves like a comet that NASA finally confirmed it. Yup, 3I Atlas really is a comet. The big giveaway is that it has an icy nucleus and a coma, which is that glowing cloud of gas and dust surrounding it. But this comet is a very special one because it didn't come from our own solar system. It came from somewhere else in the Milky Way, and that's ridiculously rare. To give you an idea, we've only ever seen 3 objects like this, period. The first 2 interstellar visits were the famous Oumuamua and the comet Borisov. And now, 3I Atlas. Cool. But you might be asking, how do we know it actually came from outside our solar system? You see, normal comets are bound to the Sun. They swing around it in these big looping orbits. But 3I Atlas isn't doing that. Its crazy speed and path show it's not on a closed orbit around the Sun. And the only logical explanation is that it came from another star system and, just wandered into ours by chance. In other words, this is just a visitor passing through our solar system, and is doing it at a ridiculous speed. When we first spotted it, it was going around 137,000 miles per hour. So this object probably spent millions of years cruising through deep space just to hang around our solar system for a few months. And after this quick visit, it'll vanish into interstellar space, and we'll never see it again. Recently, 2 European Space Agency satellites, along with several NASA spacecraft near Mars, captured new images of 3I Atlas zooming in as it passed the red planet. And one of those images is pretty incredible, showing a cloud of hydrogen atoms around the comet. Scientists were pretty excited about that, as every bit of information we get from this visitor matters. Because the reality is, there are still a lot of unanswered questions about this object, starting with its size. We can't pin it down exactly yet, but NASA says it could be anywhere from about 1,400 feet to around 3.5 miles in diameter. Its exact shape is another mystery, because our telescopes can't really get a clear look at it. The nucleus is buried inside this bright coma of gas and dust, and the sunlight reflecting off all that dust basically blinds us. So for now, we're trying to see it through a bright, dusty fog. If you put all the pieces together, its behavior, its chemistry, and the images we've gotten so far, everything points to 3I Atlas being a comet. But even with all that, there are still some pretty controversial ideas floating around about what it might be. Not long after it was discovered, Harvard astrophysicist Avi Loeb said there's maybe a 30 to 40% chance this object isn't something naturally formed. That comment kicked off a wave of online buzz, with people jumping to wild possibilities. Like maybe it's some kind of extraterrestrial tech, or worse, a threat to Earth. Ooh. According to this theory, 3I Atlas might be a massive extraterrestrial mothership. Its odd trajectory could mean it's sending out little satellites toward Jupiter to collect intel for some extraterrestrial civilization. So, in that version of the story, this isn't just a comet. It's basically advanced space spy tech. But then the obvious question is, why spy on Jupiter, right? I mean, wouldn't Earth be way more interesting to an interstellar civilization? Well, in this theory, Jupiter is the target because it's so much bigger than Earth and the other neighboring planets. The idea that a planet that massive could act kind of as an interstellar beacon, something that stands out from far away. The region near Jupiter is another big reason. It's almost like it's an ideal parking spot, where space technology could basically hang out without using much fuel at all. In other words, if you were going to place advanced satellites somewhere to watch a planet, well, that's prime real estate. Pretty cool, huh? But as fun as that theory is, we gotta come back down to Earth for a second. According to the major space agencies, this thing is a comet, case closed. But that label doesn't make it any less special. 3I Atlas is still a total weirdo in the best way, and it stands out for a bunch of reasons. Let's look at 3 of the most important ones. First, this object is old, like really old. Older than me. Scientists think it's been traveling through space for at least 7 billion years. That's so far back in time that it was formed before our Sun and Earth even existed. So yeah, it's probably the most ancient thing we've ever seen in our cosmic neighborhood. Second, its glow. Comets can sometimes look kinda green, and here's why. When a comet gets closer to the Sun, the ice inside it heats up and starts releasing gas. I know the feeling. Some of that gas is made of carbon-based molecules, especially one called diatomic carbon, or C2. When sunlight hits those molecules, they light up, and to us, that glow shows up as green. But with 3I Atlas, that green color is, well, confusing. The data suggests that this comet is actually low on those carbon chain molecules. So, the big mystery is, if it doesn't have much C2, how is it glowing green at all? Well, nobody knows. And now, the third thing that makes this comet stand out. It seems to be giving off a metal alloy we've basically never seen in nature. So this comet is releasing a plume that contains nickel. That's normal. What's strange is what's missing: iron. In comets, nickel and iron usually show up in pretty similar amounts. Here, we're seeing nickel, but no clear sign of iron. And that's almost unheard of. If the data holds up, it points to an alloy called nickel tetracarbonol, something we've only ever seen before in human-made industrial processes, not out in space. No other known object has shown this kind of signature. Well, now that you're familiar with 3I Atlas, we gotta answer the biggest question of all. Is it a threat to us? Good news! No, the comet isn't dangerous, and it's going to stay really far from Earth. So we can all take a deep breath. Well, I feel better. Although it's harmless, tracking it has been super valuable for planetary defense. You see, space agencies are always watching asteroids and comets, running the numbers on their orbits, and making sure we'd get a warning if something ever did head our way. But 3I Atlas gave them something new to practice with. This is the first time tracking data from spacecraft orbiting another planet were officially submitted to and accepted by the Minor Planet Center. That's the big global database where asteroid and comet observations get collected and checked, so scientists everywhere can stay on the same page. So, in a way, 3I Atlas was like a rehearsal. Gathering data like this from a totally new setup helps researchers sharpen their methods and improve how we spot future space objects. And that means better detection, faster tracking, and more readiness, just in case the next visitor isn't quite so friendly. Uh-oh. So get this. Earth might be actually located near space highways that could connect us to other worlds. That's because our sun sits right in the center of a giant bubble filled with hot gas, carved out by ancient supernovae. And this bubble likely has tunnels linking us to distant galaxies. So, does it mean it's time to develop space tourism? Well, let's figure it out. Most of us think space is just planets floating around in eternal darkness. But new research hints at the possibility that it might not be really true. It turns out our whole solar system is actually sitting inside a giant bubble of hot, thin gas. And it gets even better. Scientists now think there might even be a weird cosmic tunnel or channel made of this stuff. It supposedly stretches out toward faraway stars. Astronomers spent years mapping the sky, and after they put all the data together, they found something that looks like a long pathway of hot, low-density plasma, which is basically that very thin, superhot gas. And this so-called channel reaches out from around us to distant constellations. Researchers from Germany confirmed this discovery using data from a space telescope called eRosetta. We'll talk about it a tiny bit later. Now, interestingly, scientists discovered that our solar system sits inside something called the local hot bubble a long time ago. This bubble is actually a huge area, about 1,000 light-years wide. It was created when several stars exploded in giant supernovas millions of years ago. Those explosions heated up the gas around them and basically carved out this bubble of hot, low-density space. And their shock waves created weak points in the bubble around us, eventually forming interstellar tunnels. That cosmic event was so huge that the leftover hot plasma is still floating around us today. Now, to understand this bubble better, scientists used eRosetta, which is an X-ray telescope. It scans the sky looking for soft X-ray light. That's a kind of light we can't see with our eyes. It comes from hot gas, old supernova leftovers, and other structures in space. They also compared eRosetta's new information with older data from another X-ray telescope called ROSAT. And finally, putting all this information together, they were able to make a much clearer map of what's around our solar system. Mind you, this wasn't easy. They had to divide the sky into thousands of tiny pieces and carefully measure faint signals coming from warm gas, empty pockets of dust, and other stuff floating in space. But their effort paid off. After sorting through everything, they managed to figure out the faint glow of hot plasma around us. It proved we were not just drifting through empty space, we're inside a giant burned-out bubble created by extinguished stars. But what really surprised scientists was the discovery of some kind of channel. It looked like a long tunnel in space, cutting through the hot gas around us and connecting our part of the galaxy to star systems far away. They also found signs of another channel pointing toward the Canis Major constellation, and those might not be the only ones. The data suggests there could be a whole network of such paths, branching out through space. Each one works like a hidden back road. Scientists used to guess that the space around our solar system might have little pockets or rooms carved out by old exploding stars. We could probably imagine them like caves inside outer space, but no one had the necessary tools to actually prove it. But now, thanks to that new data from the eRosetta telescope, they finally have a clear picture. The telescope showed that the space around us wasn't just empty. It's full of hot, thin gas and strange shapes, including tunnels and bubbles. This proves at least part of what older scientists predicted. We're living inside a giant bubble of hot gas, and that bubble connects to other bubbles through long, low-density channels. The new study also shows that the pressure inside our bubble is lower than scientists expected. This might mean the bubble isn't closed. It could be open in some directions, letting that hot gas flow out into other parts of space. In short, this hot bubble isn't simple at all. Parts of it might be open pathways, and other parts look blocked off. Being inside it is kind of like trying to walk through a forest. Some areas have clear trails, and others are packed with trees. And even though astronomers have mapped big chunks of the bubble and found these strange channels, there's still a lot they don't fully get. Some paths look like they're made of a bunch of connected empty pockets, and others look totally closed. To understand the whole picture, we'll need better tools and more data. Hopefully, with stronger X-ray telescopes, deeper sky scans, and better computer models, we'll finally understand the nature and structure of the bubble we're living in. We might be able to make a kind of map of those hidden channels and learn how they affect things like cosmic rays, dust, and the solar wind around us. Now, speaking of telescopes, we can't help but mention the one that helped us figure out the very existence of the bubble around us. The thing is, scientists have been trying to understand a faint glow of low-energy X-rays that seem to cover the whole sky. For many years, they weren't sure where this glow was coming from. And then, the NASA-supported DXL mission finally helped to solve the mystery. Researchers used old but reliable detectors that first flew on a rocket in the 1970s. With these instruments, they confirmed that most of this X-ray glow came from a huge area of extremely hot gas around us. It was named the local hot bubble. Back in the 1990s, another X-ray mission called ROSAT made pretty good maps of the sky, and it found something surprising. Comets gave off soft X-rays too. Later, scientists realized this happened when the solar wind, fast particles from the sun, collided with neutral atoms. This process, called charge exchange, can happen almost anywhere in space. Because of this, some scientists started to doubt whether the local hot bubble was really the main source of the X-ray glow. So, to test this, DXL launched on December 12, 2012 from New Mexico. The rocket flew high above Earth's atmosphere for about 5 minutes, giving the instruments a clear view of space. The goal was to look at a worst-case situation where lots of charge exchange might occur. Right now, our solar system is moving through a cloud of cold gas in space, known as the local interstellar cloud. That's also nicknamed the local fluff. Cute, right? Neutral hydrogen and helium atoms from this cloud move through our solar system at very high speeds. Hydrogen gets affected easily by different forces, but helium mostly follows the pull of the sun's gravity. Because of this, the helium forms a focusing cone, a region with extra helium that Earth passes through every December. This cone is the perfect place to look for charge exchange, since it holds more neutral atoms than usual. But what happens during charge exchange? The solar wind comes from the sun's corona, the star's superhot outer layer. The particles in the solar wind have lost many of their electrons. When one of these particles hits a neutral atom, it can steal one of the atom's electrons. The stolen electron briefly gives off a soft X-ray. This is how the glow is created. Now, to compare things, the researchers also looked at old ROSAT data from 1990, taken in a direction away from the helium cone, where charge exchange should be weak. By putting everything together, the scientists found that only about 40% of the soft X-rays come from inside our solar system. The rest, the majority, comes from the local hot bubble. This means the huge cloud of hot gas around us really is the main source of the X-ray glow. But let's get back to the discovery of the Space Intergalactic Tunnel. It's a valuable lesson for us that space might look calm and empty when we look up, but that's not true. Space around us actually contains dust, plasma, radiation, magnetic fields, and mysterious tunnels. All of these things mix and swirl together, making space much more complicated than a simple vacuum.
Picture a silent ember drifting toward the sun, moving so quickly that no gravity well in our system can bind it. That ember, provisionally tagged 3I Atlas, appeared in late June when the Atlas Hazard Survey cameras in Hawaii and South Africa logged a faint, fast intruder. Initial orbital fits showed an eccentricity greater than 1, the mathematical stamp of an origin beyond the sun's reach. We have met only 2 such emissaries before, 1I Oumuamua in 2017 and 2I Borisov in 2019. Now a third arrives, tugging at our curiosity and our instruments in equal measure. The object's present speed is almost 70 kilometers per second, enough to span New York to London in 90 seconds. Backtracing the path leads toward the constellation Lyra. Forward projection shows a swing past Mars on 3rd October 2025, a solar perihelion 20 days later at twice Earth's distance, and final escape by early 2026. Earth stays on the sun's far side throughout, so the risk ledger reads 0. The intrigue ledger, however, is packed. Composition sits at the top of the to-do list. A comet would sprout a gaseous veil as ice evaporates, yet deep imaging has yet to reveal any coma. An asteroid would follow purely gravitational curves, yet a whisper of extra thrust may lurk in the astrometry. The James Webb Space Telescope can cut through reflected sunlight and sample the infrared glow for water, carbon monoxide, or exotic minerals. If the spectrum comes back featureless or metallic, theories multiply. Brightness fuels the puzzle. Even with a modest albedo, the observed flux implies a body several kilometers wide, far larger than Oumuamua, whose size was measured in hundreds of meters. A highly reflective hull could achieve the same luminosity with far less mass, a possibility that keeps technosignature specialists awake. Professor Avi Loeb, already known for suggesting an artificial origin for Oumuamua, is lobbying for continuous JWST tracking to test for non-gravitational acceleration. A persistent drift unaccounted for by gravity would demand explanations that push against the boundaries of conventional astrophysics. Statistics pose the second riddle. For centuries, astronomy recorded 0 interstellar passers-by. Now we count 3 in 8 years. Better sky coverage explains part of the surge, yet simulations indicate the detection rate is still high. Either the density of galactic debris is underestimated, or transient swarms are sweeping the sun's neighborhood. The Vera C. Rubin Observatory, starting full operations next year, will clarify the odds by mapping every moving speck down to faint magnitudes every few nights. Structure forms the third unknown. Light curve monitoring can reveal whether 3I spins like a platter, a spindle, or a rubble pile loosely bound by microgravity. Oumuamua's flattened shape and unexplained kick remain controversial. A repeat would strengthen calls for new physics or new engineering. Rapid tumbling might indicate past collisions, freshly exposed ice, or even deliberate attitude control. That opportunity extends well beyond the object itself. Each interstellar visitor carries isotopic fingerprints of the chemistry that shaped alien worlds. Sampling those fingerprints, even remotely, refines models of planet formation, volatile delivery, and the migration histories of giant planets. In a decade, robotic missions may be fast enough to intercept such bodies. Today, we practice with photons. Time is tight. By September 2025, the object will vanish into solar glare. By the time it re-emerges, the outbound leg will dim below major telescope thresholds. Roughly 5 months remain for the most ambitious observations. Teams are coordinating radar pings, ultraviolet spectra, and high-cadence photometry to squeeze every bit of information from the fleeting visitor. Why should the broader public care? because 3I Atlas is a tangible reminder that our solar system is not an island, but a crossroads. Somewhere an unknown star flung this body into the dark, perhaps through a near miss with a giant planet, perhaps through a cataclysmic collapse of a binary pair. After wandering for millions of years, it has brushed past our doorstep, offering a message in a bottle. The galaxy is bustling, and we are part of that bustle. Whether the newcomer proves to be ice, rock, metal, or something unprecedented, its brief appearance renews a sense of frontier. Sky surveys sharpen, theories adapt, curiosity deepens. The next discovery may come sooner than anyone expects, and when it does, the groundwork laid today will allow us to read its story more clearly. For now, astronomers chase a streak of light across CCD frames, and every clear night might deliver a clue that rewrites chapters on planetary science, or adds a footnote to the search for artifacts among the stars. In either case, the sky is not done surprising us. Origin scenarios abound. Some simulations eject 3I from a nascent planetary system after a close brush with a giant planet, while others invoke a crowded stellar nursery where passing stars fling debris across interstellar lanes. Whatever the trigger, the body has drifted for perhaps tens of millions of years, carrying the isotopic signature of an alien chemistry lab. Radio arrays will also listen for narrow-band emissions, more out of thoroughness than expectation. After Oumuamua, techno-signature protocols are standard. Scan, archive, move on, unless a signal repeats. Looking ahead, Rubin's legacy survey of space and time should uncover several interstellar objects every year, identified early enough to permit rapid robotic flybys. Concepts under study at multiple space agencies outline launch-on-alert missions that could sample surface dust or even return grains to Earth. Each discovery thus acts as rehearsal for the day we chase one down in person. Whether the outcome is ordinary or transformative, the chase itself pushes instruments, sharpens global teamwork, and teaches the next generation to aim beyond yesterday's limits.
Look at this comet! Recently, it's erupted 4 times in less than 48 hours and has become nearly 300 times brighter than normal. This is the most powerful set of eruptions the comet has had in over 3 years. Should we worry here on Earth? Well, I wouldn't say scientists are worried. They're super excited. First, let me give you a little background. 29P is what astronomers call a Centaur comet. Those are icy objects that orbit the Sun in the space between Jupiter and Neptune. What's interesting about centaurs is that they're kind of like cosmic hybrids because they're moving from one kind of space body to another. They start their life as far-out objects in a lifeless, freezing cold zone beyond Neptune. But then, over a few million years, they move inward toward the Sun because the planets of the solar system affect them with their gravity. Eventually, they turn into short-period comets. This term means they can pass close to the Sun and then slingshot back out into those icy regions. Centaurs, and their name indeed comes from a hybrid half-horse, half-human creature popular in Greek mythology, are especially interesting because they're basically leftovers from the formation of our solar system, kind of like cosmic fossils. Since they've been hanging out in the frigid outer solar system for so long, they've kept a lot of the volatile materials that were present when the solar system was first forming. This makes them a valuable clue in understanding how our solar system evolved. That's what makes scientists so enthusiastic. Now, about 29P itself. This thing is huge for a comet. It's about 37 miles across, which is almost 3 times the length of Manhattan. Now, worry not, it's too far away to cause us any harm. While it's one of up to 1,000 known centaurs, 29P is also in a rarer group of comets called cryovolcanic comets. Those are a fascinating class of space objects that have unique geological activity. The thing is, cryovolcanic comets not only contain a unique mix of ice, dust, and rock, but also feature cryovolcanoes, aka cold volcanoes. They erupt with volatile materials like water, ammonia, or methane instead of molten rock. As for regular comets, when they approach the Sun, the heat from the star evaporates their gases, leading to the emissions of dust and tiny particles, electrons, and ions. These materials create those magnificent trails. These eruptions are incredibly spectacular and make the comet appear a lot brighter since the cloud of cryomagma reflects the sun's light. The cloud that forms around the comet is called the coma, and it can grow so large and bright that it makes the comet look like a fuzzy ball of light. If you've ever observed a comet, the coma is the halo you see around it. Such eruptions are pretty unpredictable. While most cryovolcanic comets follow elliptical orbits that take them far out into the solar system, 29P is on a more circular orbit, staying around the same distance from the Sun as Jupiter. You'd think that this would mean its eruptions would be more regular, but that's not the case at all. In fact, 29P erupts in a completely random and unpredictable way, and scientists are still trying to figure out why. The latest outbursts started on November 2, 2024, when 29P erupted for the first time in almost 2 years. This was followed by 3 more large eruptions in less than 48 hours, which really got the attention of astronomers at the British Astronomical Association. They'd been tracking 29P for a while, and they reported that the eruptions sent out a cloud of debris reflecting about 289 times more light than the comet's nucleus, which is a huge increase in brightness. Astronomers are expecting that the coma, which is growing after each eruption, could take on an unusual shape. The multiple outbursts might cause the coma to expand in a weird, irregular way. This is especially interesting because 29P hasn't had a major eruption like this since November 2022. Then it threw out over 1 million tons of debris. The last time it had a massive outburst was in September 2021, when the comet had multiple eruptions in quick succession. In addition to the confusion about its eruptions, 29P is pretty different from most other comets. Most comets have elliptical orbits that take them far out into the solar system. They spend decades, centuries, or even thousands of years far from the Sun, only to erupt when they get close. But 29P doesn't do that. No, it orbits the Sun once every 15 years and stays at about the same distance as Jupiter. This strange behavior makes astronomers even more eager to figure out what's going on with it. Another cool thing about 29P is that it doesn't ever get close enough to the Sun to grow a tail like other famous comets, such as the once-in-a-century comet, Tsuchinshan Atlas, which has recently made headlines. It passed the closest to Earth in 80,000 years. NASA's James Webb Space Telescope has been keeping an eye on 29P, helping solve some of the mysteries about the comet. And it has recently made another groundbreaking discovery. It has detected jets of CO2, good old carbon dioxide, coming from the comet. This was the first ever detection of CO2 jets on this particular comet. Webb has also discovered a jet of carbon monoxide coming from the comet. It can tell us a lot about the composition of the comet and its outbursts. What's especially interesting is that the jets seem to come from different parts of 29P's nucleus. Even though Webb can't actually figure out the nucleus itself because it's too small to see in detail, the jets coming from different locations on the comet's surface suggest that the nucleus may be made up of multiple objects. These objects might have different compositions, and it's possible that the nucleus is more of a composite body made up of smaller chunks that came together over time. Strangely, astronomers haven't detected any water vapor in the comet's atmosphere. That's unusual because the atmospheres of most comets often contain water. Our comet might lack water vapor due to the extremely cold temperatures on its surface. It could prevent water from evaporating or vaporizing. 29P isn't the only thing that Webb is studying. The telescope has also been making some big discoveries about galaxies far, far away. For example, Webb has recently spotted a galaxy with a pretty complicated name which appeared about 1 billion years after the Big Bang. What's super weird about this galaxy is that the gas in it is shining brighter than the stars, which is really rare. This could be a missing link phase in the evolution of galaxies, something that could help astronomers understand how galaxies transition from the very first stars, called population 3 stars, to the types of galaxies we see today. The stars in this galaxy are much hotter than we see in modern galaxies in local universe, around 144,000 degrees Fahrenheit, compared to the typical 72,000 to 90,000 degree Fahrenheit of stars today. This could mean that the galaxy is in the middle of a super brief but intense phase of star formation, where huge, hot stars are popping up in a dense gas cloud. And this gas cloud is glowing so brightly because it's being hit with tons of light from these stars. The research team behind this discovery says that although the galaxy doesn't have population 3 stars, because the data shows it has too much chemical complexity, it still could be a guide for understanding how galaxies evolved, from the first stars to the galaxies we're familiar with today. There are still so many questions about this galaxy. Is it a rare phase? Or is it something that happens often in the early stages of galaxy formation? Astronomers are hoping to study more galaxies like this one to figure it out.
Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed Oumuamua. This means a visitor from a faraway land in Hawaiian, or that's a really big cow. It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the sun, it sped up, like it had a rocket on it. And it wasn't the sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. that traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space.
Did you know that over the past year, around 150 asteroids whizzed closer to Earth than the Moon? But that's not the scary part. It's that some were only noticed after they flew by. And if even one of those had taken a slightly different path, whole cities would be gone. That's what keeps the scientists worried. The invisible stuff hiding where our telescopes can't see. Let's explore what that means. Astronomers keep a list of asteroids that wander into our neighborhood. If a rock's orbit comes close to Earth, it joins a special club we call Near-Earth Objects, or NEOs. That list can include anything from a harmless little space pebble that wouldn't break a window to a rock big enough to cause an earth-shattering kaboom. NEOs are leftover materials from when the planets were forming. Some of that rubble ended up tucked safely in the asteroid belt between Mars and Jupiter, but some pieces got nudged onto paths that cut across Earth's orbit. Those are the ones we care about, because they're still wandering around today, looping around the sun, and every now and then passing uncomfortably close to us. The biggest objects are the easiest to locate. They are rare and bright enough that they stand out in sky surveys. So far, none of those big ones seem to be heading our way anytime soon. However, the real anxiety comes from the middle class of asteroids. On paper, many of them sit in the potentially hazardous object category, or PHOs, but the nickname City Destroyer explains them better. These rocks aren't huge enough to wipe out the planet, but they could flatten a city and mess with the climate for a few seasons. Some are as wide as a football stadium and hit the atmosphere faster than a speeding projectile. NASA estimates there are around 25,000 near-Earth asteroids at least 460 feet wide, but we've only discovered a fraction of them. Basically, we have solid orbits for less than half of the City Destroyer crowd. The rest only exist as numbers in simulations. We know they should be out there. We just haven't seen them yet. Why are they so hard to spot? Some asteroids are nearly coal black, blending into the cosmic night. Others hang out close to the sun from our perspective, so our telescopes get overwhelmed by brightness. It's like trying to locate a mosquito while staring directly at the sunlight. Please don't do this. From Earth, these rocks are mostly lost in the sun's glare. We only catch a glimpse just after sunset or right before sunrise. And that chance only exists if the sky is perfectly clear and the asteroid happens to be in exactly the right spot. If not, it slips back into the sun's blind spot, playing hide and seek with us. We were caught by surprise quite recently. In 2013, the Chelyabinsk meteor came from the direction of the rising sun. No one saw it in time because it was coming from the wrong direction. It exploded high above the region, shattering windows across the city and sent more than 1,000 people to the hospital. The scariest part is that the meteor was only about 60 feet wide. Now imagine a city destroyer coming from that same direction. A stadium-sized rock stepping out of the sun's glare would give us very little warning, maybe a few days or a week instead of decades. And we know that the blind zone is not empty. Observations have already revealed at least one large asteroid in that region that scientists can seriously consider a planet destroyer. It's called 2022 AP7, and it's huge. This thing is more than half a mile wide, big enough that if it ever hit Earth, it would be a catastrophic day for everyone. Astronomers found it by using the super-sensitive dark energy camera during twilight, pointing the telescope at the region of the sky most surveys normally avoided. The good news is that AP7 isn't headed straight for Earth. Its orbit crosses the orbit of our planet, but the timing doesn't line up, so we won't encounter it this pass, the next one, or even for several centuries. The bad news is what that discovery hints at. If it took this much effort to notice something like this, what else are we missing? And 2022 AP7 is just one PHO. Other asteroids closer to the sun were also spotted during those same twilight searches. New simulations say some of those hidden rocks are not random. A bunch of them seem to share an orbit with Venus. They do not orbit Venus itself. They orbit the sun in almost the same lane, sometimes a bit ahead of the planet. sometimes a bit behind, like kids jogging on the same track but spread out along the lap. Astronomers already know about roughly 20 of those Venus co-orbitals, and their paths are anything but stable. Gravity from Venus, Earth, and other planets keep tugging on them, and over thousands of years, those pulls could stretch their paths until they start crossing Earth's orbit. Most flybys are harmless, but one unlucky pass could be the one that counts. So what can we do about this? The first step is simple in theory. Find them earlier. The goal for astronomers is to launch infrared telescopes and get them into space. While we do have amazing telescopes like JWST or the Hubble Space Telescope, they're never pointed at the sun, as the brightness of our star can damage them. That's why we need a telescope in orbit around Venus, or one that travels along with it. It would be in a much better spot to keep an eye on the asteroids that hang out there. NASA is launching the NEO Surveyor project that aims to solve the problem. It should scan the inner solar system to spot dangerous asteroids in time. Also, we're learning that we can actually move asteroids. NASA's DART mission rammed a small spacecraft into a rock, which affected its orbit slightly. Not by much, just enough to prove that it can be done. It's like turning a plane just 1 degree while it's still across the ocean. By the time it reaches you, that tiny change can make it miss by thousands of miles. Teams around the world spend their days babysitting space rocks, and yes, that's a real paying job. NASA has the Planetary Defense Coordination Office. Europe has the NEO Coordination Center. Observatories feed them nightly sky data, and computers immediately check each dot's orbit. If a rock might wander too close, it joins the risk list and gets extra attention. Each new photo updates the orbit a little more. Sometimes that make the danger level rise for a moment. That is exactly what happened with 2024 YR4, when it briefly reached level 3 on the Torino scale before better measurements calmed everyone down. The scale itself runs from 0 to 10, and anything that climbs above 3 is rare enough to raise eyebrows. The whole system works that way on purpose. Notice something strange, collect more data, then decide whether to relax or stay alert. Most of the job is actually pretty dull. It's a lot of number checking, orbit fixing, and crossing out false alarms. That quiet, careful routine is what lets the world respond quickly when a rock finally appears that isn't just passing by. So how worried should we be? For those huge planet-destroying rocks, the short answer is not much. Nothing that size is on the near-term schedule. Smaller city-level threats are trickier. The odds of one hitting Earth anytime soon are still tiny, but they're not zero. Think of it as a cosmic lottery that has been running for billions of years. Every once in a very long while, the universe draws a number that makes astronomers sit up and pay attention. It's not a reason to panic. It's a reason to build better eyes in space and make sure that if a bad ticket ever comes up, we see it in time to do something about it. While you're watching this video, pieces of continents are slowly breaking off from below and are pulled down into the oceanic mantle, a hot, mostly solid layer that moves slowly under the seafloor. As soon as these fragments reach the mantle, they can trigger volcanic eruptions in parts of the ocean where there are no volcanoes. Plus, when continents break apart, it happens not only at the surface, but also deep down. But more on that later. This process can continue for tens of millions of years. The new study shows that Earth's insides are even more dynamic than we thought. It also explains why many volcanic islands, including Christmas Island in the Northeast Indian Ocean, contain unusually high levels of certain chemical elements. The thing is, these elements are normally only found in continental crust. Well, scientists did suspect that these elements showed up because some powerful forces deep inside the Earth took old, recycled pieces of rock and mixed them into the mantle. This process works a bit like when you mix together ingredients for cake batter. But before, researchers believed those elements came from two main sources: sediment that sank into the mantle as oceanic plates got pushed down, or from mantle plumes. Those are columns of hot rock rising up from deep inside Earth. However, these explanations don't fit all observations. In some volcanic areas, there's almost no sign that the crust has been recycled. In other places, the mantle seems to cool and too close to the surface to be affected by the rising hot rock. Scientists used to wonder how this could happen. Now we know that some of the material in those regions comes from pieces of continents that sink deep into the mantle, and these pieces affect the volcanoes that form above. The new study also suggests a curious idea. Continents don't just break apart at the surface, they peel away from below too. And this can happen over much greater distances than scientists thought before. Researchers used simulations to figure out how continents and the mantle behaved when stretched by tectonic forces. Their work is built on earlier research showing that when continents split, deep, powerful forces inside our planet create a mantle wave. This wave moves along the base of the continent at depths of about 90 to 125 miles. The wave moves extremely slowly, about a millionth of the speed of a snail, and gradually strips material from the roots of the continents. These peeled-off fragments are then carried sideways, sometimes more than 620 miles, into the oceanic mantle. Once there, they can trigger volcanic eruptions in the ocean for tens of millions of years. The research also shows that the mantle continues to feel effects of continental breakup long after the continents themselves have separated. Even after a new ocean basin forms, the mantle keeps moving, reorganizing and transporting enriched material far from where it originally came. To make this conclusion, researchers studied geochemical data from different parts of the Earth, including the Indian Ocean Seamount Province. That's a chain of volcanic formations that appeared after the supercontinent Gondwana had broken apart over 100 million years ago. Their computer models and chemical tests showed that right after the supercontinent Gondwana broke apart, a lot of magma with unusual chemicals pushed up to the surface. Over millions of years, this chemical signature slowly faded as less material came up from under the continent. The most unexpected discovery is that this happened without any help from those deep, hot columns of rock scientists used to think were needed. Now, to get an even clearer picture, let's sneak a peek into our planet's insides. Earth is about 4.6 billion years old. It was born from a huge cloud of dust and gas that slowly cooled, shrank, and hardened into the planet we know today. As it cooled, heavy metals like iron and nickel sank to the center, and lighter, rocky materials floated upward. This created the Earth's layered structure, with each layer having its own unique properties. The crust is like Earth's skin. It's our planet's outermost layer, made of solid rock. It's broken into huge pieces called tectonic plates that slowly drift over time. There are two kinds of crust: oceanic crust and continental crust. The oceanic crust is about 4 to 6 miles thick. It's covered with a thin layer of sediments like sand, clay, and shells. Below that are dense rocks like basalt, rich in magnesium. As for the continental crust, it's thicker than oceanic crust and is located under continents. It's made of lighter rocks than oceanic crust. Beneath the crust is the mantle. It makes up more than 75% of Earth's volume. The top of the mantle is pretty rigid, but deeper down it becomes soft and partially molten, which allows it to flow slowly. This flow is what moves the tectonic plates. At the center of the Earth lies the core. It's made mostly of iron and nickel and has two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel. It's insanely hot, up to 10,800 degrees Fahrenheit, as hot as the surface of the sun. The outer core also generates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is solid because of the crushing pressure inside the planet, It's also made of iron and nickel. Now, the Earth's outer shell, called the lithosphere, is made up of the crust and the uppermost part of the mantle. It's broken into large pieces, called tectonic plates. There are a few super large plates and many smaller ones. 6 of the major plates are named after the continents they carry, like the North American, African, and Antarctic plates. But even those smaller plates play an important role. For example, the tiny Juan de Fuca plate is responsible for many of the volcanoes in the Pacific Northwest of the United States. The plates are moving like a jumble of old conveyor belts. They move very slowly, about 1 to 2 inches per year. But over millions of years, this movement shapes the face of our planet. Most earthquakes, volcanoes, and mountain building happen where plates meet, pull apart, or slide past each other. There are 3 main types of plate boundaries: convergent, when plates move toward each other; divergent, when plates move apart; and transform. That's when plates slide sideways past each other. When tectonic plates collide, the crust crumples and buckles, forming mountain ranges. About 55 million years ago, India crashed into Asia, slowly creating the Himalayas, the tallest mountains on Earth. The collision continues today, so the mountains are still rising. Mount Everest, the highest point on Earth, may even grow a tiny bit taller over time. At some convergent boundaries, an oceanic plate dives under a land plate in a process called subduction. The land above lifts up, forming mountains, and the sinking plate melts and triggers volcanic eruptions. This is how some mountains in the Andes of South America were formed. When 2 oceanic plates collide, one usually slides beneath the other, creating deep ocean trenches, like the Mariana Trench in the North Pacific, the deepest point on Earth. These collisions can also form underwater volcanoes that eventually rise above the ocean and turn into island chains, such as Japan. At divergent boundaries, tectonic plates move away from each other. In the oceans, magma from deep in the mantle rises to fill the gap. This creates underwater mountains and volcanoes along the seam. This process renews the ocean floor and slowly widens the ocean basins. By the way, a single mid-ocean ridge system connects all the world's oceans, making it the longest mountain range on Earth. On land, when plates pull apart, they form giant valleys, such as the Great Rift Valley in Africa. If this stretching continues over millions of years, East Africa could split off to become a new landmass. One famous example of transform boundaries is the San Andreas Fault in California. Unlike convergent or divergent boundaries, transform boundaries usually don't create mountains or oceans, but the grinding motion can cause powerful earthquakes, such as the 1906 earthquake that destroyed much of San Francisco.
3, 2, 1, 0.
In 1977, NASA sent the Voyager spacecraft to explore the outer parts of the solar system and the space beyond. And at one point, the probes ran into something totally nightmarish: a blazing wall of fire measuring temperatures from 54,000 to 90,000 degrees Fahrenheit. Well, did the probes manage to survive these intense conditions? We'll find out soon. Meanwhile, there are several ways to think about where the solar system ends. One way is to say it ends where the planets stop. Another way is connected to the Oort cloud. That's a giant group of icy objects far beyond the planets, the farthest region of the solar system. It is extremely distant, maybe a quarter to halfway to the nearest star. To understand such huge distances, scientists often use something called the astronomical unit, or AU. 1 AU is the distance between Earth and the Sun. For comparison, Pluto orbits between about 30 to 50 AU from the Sun. The inner edge of the Oort cloud is thought to be much, much farther away, and the outer edge could be even further away. These distances are very hard to imagine. My little brain sputters when considering such. Now, we can also measure them in time instead of miles. NASA's Voyager 1 spacecraft makes almost 1 million miles per day. At that speed, it would take about 300 years to reach the Oort cloud and maybe 30,000 years to reach its outer edge. Now, one more way to define the edge of the solar system is by the sun's gravity. It might be the area where the sun can still pull objects back toward it. And finally, we can define it by considering the heliopause, the boundary where the sun's influence ends. You see, the sun constantly sends out charged particles in a flow called the solar wind. This wind moves past all the planets and reaches about 3 times the distance to Pluto. The solar wind creates a giant bubble around the sun and planets called the heliosphere. The heliopause is the outer edge of this bubble, where the solar wind meets the wind coming from other stars, called the interstellar wind. Here, the pressures from the solar wind and the interstellar wind balance each other. This causes the solar wind to turn back and flow along the tail of the heliosphere. As the heliosphere moves through space, it creates a bow shock, similar to the wave that forms in front of a ship moving through the water. So, depending on how you define it, by planets, by the Oort cloud, by gravity, or by the sun's magnetic influence, the edge of the solar system can mean very different distances. But if we talk about the Voyagers, they came across something intense. It was something we could probably call a wall of fire, blazing heat and intense temperatures. The 2 probes became the first spacecraft to travel beyond the heliosphere and cross the heliopause. Before the Voyager spacecraft reached the heliopause, scientists did not know exactly where this boundary would be. But the fact that the 2 spacecraft crossed it at different distances helped confirm some predictions about the heliopause. Scientists did expect that the edge of the heliosphere could move as the sun's activity changes, a bit like a lung expanding and contracting as we breathe. And the fact that Voyager 1 and Voyager 2 encountered the heliopause at different distances matched this expectation. The heliopause is not a hard edge or solid wall, but the nickname Wall of Fire actually matches the nature of that insane region. Both spacecraft measured extremely high temperatures there, around 30,000 to 50,000 Kelvin, or 54,000 to 90,000 degrees Fahrenheit. Despite these extreme temperatures, the spacecraft were safe. The particles in this region are very far apart, so collisions are rare and not enough heat could reach the spacecraft to harm them. Nearly 50 years after their launch, Voyagers 1 and 2 continued to send back data from beyond the heliopause. They are the only 2 spacecraft that have crossed this boundary so far. Together, they have already made several curious discoveries about space outside the solar system. For example, Voyager 2's magnetic field measurements confirmed a surprising result from Voyager 1. Just beyond the heliopause, the magnetic field lines are aligned with the magnetic field inside the heliosphere. Before Voyager 2, scientists only had one measurement from Voyager 1, so they could not be sure whether this alignment was real or just a coincidence. Voyager 2 confirmed that the alignment was real. The magnetic fields inside and just outside the heliopause apparently run in parallel. These discoveries give scientists important information about the structure and behavior of space beyond the solar system. Now, let's dig a little deeper into the Voyager program itself. It's made up of 2 spacecraft, Voyager 1 and, wait for it, Voyager 2. Even though Voyager 2 was launched first in August 1977, Voyager 1 took off just 2 weeks later on a faster, more direct path. These 2 spacecraft have been traveling for more than 40 years, exploring worlds no human will ever walk on, at least in the near future. The 2 Voyager spacecraft are nearly identical. Each has a large radio dish that is 12 feet across. This dish sends data back to Earth. They also have 16 thrusters to control their direction and make sure the dishes always point toward our planet. The thrusters use special hydrazine fuel, and the spacecraft's electronics are powered by thermoelectric generators that run on plutonium. Each Voyager carries 11 scientific instruments. About half of them were made specifically to study planets, and most of those are now turned off. The turned-off instruments include several cameras, spectrometers, and 2 radio-based experiments. During their long journeys through the solar system, the Voyagers took tens of thousands of images and measurements. This data has changed what we know about the outer planets. When the Voyagers reached Jupiter, they gave us our first detailed look at the planet's atmosphere. They showed that the Great Red Spot was a huge storm spinning counterclockwise and interacting with smaller storms nearby. The Voyagers also discovered a faint dusty ring around Jupiter. They studied Jupiter's moons, too. They found volcanoes on Io, saw linear features on Europa that hinted at a hidden ocean beneath its icy surface, and confirmed that Ganymede is the largest moon in the solar system, larger even than Saturn's moon, Titan. Next, the spacecraft flew past Saturn. They measured the planet's atmosphere and studied its famous rings, discovering gaps and waves we still see today. Voyager 1 looked through Titan's thick haze and suggested that the moon might have liquid hydrocarbons on its surface. It was later confirmed by other missions. Voyager 1 also found 3 new moons orbiting Saturn: Atlas, Prometheus, and Pandora. So that's where she ended up. After Saturn, Voyager 1 continued out of the solar system, while Voyager 2 headed toward Uranus. Voyager 2 discovered 11 new moons and 2 new rings there. It also observed strange features, such as Uranus's unusual magnetic field and a surprisingly small temperature difference between its equators and poles. Voyager 2's final planetary stop was Neptune. It happened 12 years after leaving Earth. There, it discovered 6 small moons and rings around the planet. It studied Neptune's atmosphere and magnetic field, and observed volcanic vents on Triton, Neptune's largest moon. After this, Voyager 2 joined Voyager 1 on its journey toward interstellar space. Voyager 1 entered interstellar space in August 2012, and Voyager 2 joined it in November 2018. These missions helped scientists measure the edge of our solar system, about 11 billion miles from the Sun. The spacecraft still sends back data about this mysterious region. By the way, after its planetary visits, Voyager 1 took the famous pale blue dot photo of Earth from about 3.7 billion miles away. Today, Voyager 1 is about 15.8 billion miles from Earth, and Voyager 2 is about 13.1 billion miles away. Each Voyager carries a golden record, a time capsule from Earth for other civilizations it might meet. The record covers include instructions for playing it, a map showing Earth's location, and a drawing of a hydrogen atom. The records are cleverly plated with uranium, so the decay of the uranium could help discoverers figure out when the record was made. The records contain 115 images showing Earth, humans, animals, plants, and our solar system. They include natural sounds like waves and birdsong, greetings in 55 languages, brainwave recordings, and a mix of music, ranging from Beethoven to Chuck Berry and folk songs. Oh man, the Sun did it again! It just blasted a huge cloud of plasma into space. This time, it was one of the fastest and most powerful eruptions of this solar cycle. It was so strong that the shockwave hit Venus, our next-door neighbor. That's when scientists got worried and started asking a scary question. Could Earth be next? Well, let's just cut to the chase. If your GPS and internet have been working fine over the last few weeks, and your city hasn't had any big blackouts lately, you already know the answer. No, that powerful blast didn't hit Earth. Or at least we didn't feel any real effects from it, because this event happened in October 21st, 2025. And if our planet had been in its path, we would have felt the effects only a few days after that date. You see, we're talking about coronal mass ejections, or CMEs. From time to time, the Sun throws a giant cloud of superhot plasma into space, straight from its outer layer, the corona. Think of plasma as a superheated gas. It's what the Sun is made of, and it's full of tiny charged particles, positive ions and negative electrons. These outbursts happen because the Sun's magnetic field is always moving and twisting. Sometimes the magnetic lines get tangled up, then suddenly snap and reset. This process is known as a magnetic reconnection. And when that happens, boom, the Sun launches a CME. A single coronal mass ejection can throw billions of tons of material into the solar system in one shot. and it can create a shock wave. That shock wave can speed up charged particles, which raises the chance of a radiation storm. And if a planet is in the way, yeah, that can be trouble. The tricky part is that CMEs are pretty unpredictable. They can blast out in different directions, and they don't all move at the same speed. The fastest ones race through space at millions of miles per hour. If one is aimed at Earth, it can get here in as little as 15 hours. Slowest ones can take days to get here, but even then, it's usually somewhere between 1 and 5 days. It's not like months. Since this big blast happened a while ago, it's safe to say that, well, we're safe. And honestly, even if it had hit Earth, we'd probably be safe anyway. Sure, a strong CME can mess with satellites, disrupt radio and internet signals, and even knock out power grids for a while. But it's not the kind of thing that ends the world or wipes out humanity. So, take a breath. Even a really powerful solar eruption isn't going to destroy Earth. Unfortunately, we can't say the same thing about Venus. CMEs hitting our neighboring planet are actually one of the reasons Venus can't support life, at least not what we consider life. But don't worry, we'll get to that part later. First, let's dive into this recent solar outburst and what made it so extreme. This one came from the far side of the Sun, the side we can't see from Earth, and it came from an especially active sunspot area called 4246. This is a new, huge, messy sunspot that's been responsible for the latest round of solar storms headed our way. The big blast happened right after that region rotated past the Sun's western edge, so it was out of view from Earth and from most weather satellites. Thankfully, the event was caught by an instrument on a NOAA satellite called CCOR-1. Think of it like a special camera designed to spot big solar blasts even when they happen on the far side of the Sun. That's why it's strategically placed so high above Earth, and it orbits about 22,000 miles over the equator. The CCOR-1 manages to capture those images by blocking the Sun's blinding surface, so it can see the faint glow around it and track huge plasma clouds as they spread out into space. Now, let's talk about speed. NASA estimates that the CME in October was moving at about 820 miles per second. But the first radio signal suggested it might have been even faster, close to 1,537 miles per second. Trust me, that's crazy fast for a coronal mass ejection. To put that in perspective, only a handful of blasts in modern history have been quicker. One famous example happened in 2017 during an X-class flare rated around X8. So according to NASA, X-class means the strongest kind of solar flare. The number tells you how strong it is. An X1 is the baseline, an X2 is twice as strong, an X3 is 3 times as strong, and so on. So yeah, an X8 flare is something huge. Back on Earth, that 2017 event did mess a bit with high-frequency radio signals for a while. But for us, that was pretty much it. Mars was a different story. When the same event hit the red planet, it heated the upper atmosphere in an uneven way. In the hottest areas, scientists saw the top 2 layers, the thermosphere and the ionosphere, start interacting more than usual because of the blast. And that had a real effect. Oxygen began escaping into space much faster than normal. In other words, that brief event made Mars lose part of its atmosphere at a higher rate. Now, when we talk about this recent burst, the story is kind of similar, but with a twist. This time, Mars wasn't the main target, Venus was. The planet was sitting right in the path of the solar burst. So when the blast hit, Venus got slammed with a storm of charged particles. Now you might be wondering, why is it a bigger problem when a solar eruption hits planets like Venus or Mars, but not as big of a deal for us here on Earth? Well, it's because of Earth's magnetic field. So big blasts from the Sun can mess with the atmosphere around a planet. But on Earth, a lot of that impact gets blocked by a natural magnetic bubble called the magnetosphere. Good thing, huh? Here's how it works. A wave of plasma comes from the Sun and slams into the magnetosphere, the region around Earth controlled by our magnetic field. That magnetic field pushes most of the charged particles away, kind of like a shield, but not all of them. Some particles still sneak through and crash into the upper atmosphere. When that happens, we can get geomagnetic storms. These storms create amazing auroras. They can also mess with satellites and communication networks, like we talked about earlier. But some planets, like Venus, don't have a strong magnetic field like Earth does, and that can be bad news. Because when a CME wave reaches Venus, the charged particles crash straight into the atmosphere and, over time, slowly peel parts of it away. Now here's a real example. On December 19, 2006, the Sun released a small, slow CME. Even though it wasn't moving fast, it was still strong enough to do damage. About 4 days later, it reached Venus and ripped away a large amount of oxygen from the planet's atmosphere, sending it off into space for good, or bad. And this is actually one of the big reasons why planets like Venus are uninhabitable. Without a strong magnetic field, CMAs can slowly strip away their atmosphere, blast the surface with dangerous radiation, and create brutal space weather conditions. Venus is a perfect example. It is the hottest planet in our solar system, being 100 times hotter than Earth. Its atmosphere is insanely thick, and the pressure over there is insane, so much so that the longest any spacecraft has survived on its surface before being crushed is a little over 2 hours. Scientists think that getting hit by solar eruptions without a proper magnetosphere to protect it helped push Venus toward this extreme world. And by studying what happens to planets like Venus, we can learn something bigger: how important a magnetic shield might be for life on other worlds we find outside our solar system. This is a typical crater on the Moon. It's here because, once upon a time, an asteroid crashed right into it. Yep, a lunar crater forms when an asteroid, meteoroid, or a comet slams into the Moon's surface. And as you can see, it's happened a lot. But one crater formed in a very different way. But then, how did it form? Well, let's rewind a bit. There's a widely accepted hypothesis that the Moon itself is a product of collision, just like all these craters. But that collision was way, way tougher. It happened over 4.5 billion years ago when a huge Mars-sized planet called Theia crashed into Earth. That event threw a bunch of debris into orbit. Eventually, it came together to form the Moon. Now, for a while after that, the Moon was basically a giant ball of lava. But because the early Moon was very close to Earth, our planet's gravity kept squeezing it, making it even hotter. In the end, though, the Moon drifted farther away, cooled down, and formed a rocky crust. Now, moving on, about 4.3 billion years ago, an asteroid the size of a small country, like Nepal, way bigger than the one that wiped out the dinosaurs, slammed into the Moon's far side. It left an enormous crater called the South Pole Aitken Basin. It's up to 5 miles deep and about 1,500 miles wide. For comparison, that's roughly the distance from New York to Dallas and deep enough to swallow Mount Everest. Now, scientists think that impact may have dug up and scattered some ancient stuff from deep inside the Moon. A mixture of materials nicknamed creep, short for potassium, rare earth elements, and phosphorus. It's like a chemical time capsule from when the Moon was still a lava ocean. Now, you want to know the reason why this area could be even more scientifically interesting than we realized? You see, until recently, researchers believed the asteroid came from the south, slamming upward and spreading a bunch of radioactive material, that very creep, around the crater's northern rim. But after looking closer, scientists realized the impact actually came from the north, which means all that valuable creep ended up on the southern edge instead. And guess what? NASA's Artemis 3 mission happens to be targeting that exact southern region. Researchers started questioning the old southern impact theory when they compared the Moon's crater with others across the solar system, mainly Mars's Hellas Basin and Pluto's Sputnik Basin. Here they are. See? All three have this bizarre teardrop or avocado shape, wide on one side and pointy on the other. And exactly that pointy end usually shows which direction the asteroid came from. In the case of the South Pole Aitken Basin, that means the asteroid hit from the north, not from the south. To confirm it, scientists dug into old data from NASA's Lunar Prospector mission. It orbited the Moon in 1998 to 1999. That spacecraft measured radioactive elements on the surface and found high concentrations of thorium, a key part of creep, around the basin's southwestern rim. Now, the Artemis 3 mission is NASA's big plan to put humans back on the Moon for the first time since 1972. If everything goes according to schedule, the launch is set for mid-2027, right after Artemis 2 wraps up. See, Artemis 2, which is supposed to launch before April 2026, will be sort of a dress rehearsal. Astronauts will orbit the Moon without landing, just to make sure that all the systems work smoothly, a cosmic test drive. Artemis 3 is where things are going to get real. The astronauts are expected to land near the Moon's south pole, in one of 9 possible locations NASA has scouted out. The only problem is timing. Artemis 3 has already been delayed a few times, and so has Artemis 2. Artemis 1 launched in 2022. It was an uncrewed test flight that went around the Moon and came back just fine. So, next up is Artemis 2, which will take real astronauts further into space. Then comes Artemis 3, the big one. Astronauts are supposed to hang out on the lunar surface for about a week doing sciencey stuff before heading home. After that, Artemis 4 and 5 will build and expand a new mini space station orbiting the Moon. It's called Gateway. Think of it as a pit stop in space. Astronauts can dock there, live for short missions, do experiments, and prepare for landings. NASA's building it with help from the European Space Agency, Japan, and a few others. The astronauts are going to travel in the Orion spacecraft, launched by NASA's Space Launch System, a massive rocket taller than the Statue of Liberty and strong enough to fling people to the Moon. To actually land, they'll use the Human Landing System. SpaceX's Starship is supposed to take the first cruise down to the Moon's surface once it proves it can land safely. In the long run, NASA's not going to stop at the Moon. The big goal is Moon to Mars. Hopefully, we can use everything we learned from Artemis to build a lunar base and eventually send humans all the way to Mars. And who knows? Maybe when people land on the Moon, they'll be able to figure out another unsolved mystery: flickers, glows, or beams of light that sometimes illuminate our satellite. Let's dig deeper into this mystery, shall we? On the night of April 19, 1787, astronomer William Herschel spotted something weird: a bright light glowing on the dark part of the new moon. It shone for hours and was almost as bright as the Orion Nebula. What he saw probably was what scientists now call a transient lunar phenomenon, or TLP. Basically, quick little flashes or color changes on the moon's surface. TLPs can look like glowing patches, reddish or purple spots, or even hazy clouds that suddenly appear and fade away. Over the last 2,000 years, people have recorded around 3,000 of these strange moon flashes, using telescopes, cameras, or sometimes just their own sharp eyes. So, what's really going on up there? Well, there's no single answer. Lots of different things can cause TLPs, from meteor impacts to gas releases or even electrical activity. The length of the flash, which can last anywhere from a split second to several hours, gives scientists clues about what's behind each mysterious lunar light show. The super short flashes, lasting less than a minute, are most likely caused by tiny space rocks crashing into the moon. Even a meteoroid, the weight of a billiard ball, can hit the lunar surface hard enough to make it glow for a split second. The heat from the impact makes rocks shine and then quickly fade as they cool down. For a long time, scientists suspected these quick flashes were caused by meteor hits. But they couldn't prove it until the 1990s, when high-speed cameras finally became common in lunar research. Even then, it wasn't easy to confirm. Short flashes could have just been camera glitches or electric noise. The only way to be sure was to catch the same flash from 2 or more places at once. Well, that happened for the first time during the Leonid meteor shower in 1999, when scientists recorded real impact flashes on the Moon. Later, we got more proof that the Moon was often peppered with space rocks. While the flashes seemed to cluster in certain areas, like Oceanus Procellarum, one of the Moon's big dark plains, that's likely just because of where scientists have focused their cameras. A 2024 study showed that meteoroids actually hit the Moon evenly everywhere. Now, flashes that last a few minutes are probably caused by something totally different – gas leaks from inside the Moon itself. Studies from 2008 and 2009 found that when gas like radon builds up under the lunar surface, it can suddenly burst out. Hey, I know how that feels. And when this radioactive gas escapes and decays, it gives off a faint glow we can see from Earth. Interestingly, those glowing spots often line up with areas where scientists have already found higher radon levels. Then, there are the long-haul lights. They stick around for hours, like the bright glow William Herschel saw back in 1787. A 2012 study suggested those could actually be caused by solar wind, a stream of charged particles coming from the sun. When that solar wind hits lunar dust, it can charge up the particles and toss them into the air, well, into space, creating massive dust clouds up to 60 miles high. These floating clouds might bend or reflect light from stars or planets nearby, making it look like the Moon itself is glowing. So hopefully, we'll get the answers once the Artemis mission lands and starts its exploration. Hey, I can hardly wait. You know, our planet can be absolutely breathtaking if you know where to look. From Greenland's green waves to deserts glowing like molten gold, the planet looks like living art. But there's something even better than knowing what to look for. It's knowing where to look from. For example, from a few hundred miles above the ground, where satellites are, so you can see faces in deserts, hearts in sand, spirals, skulls, and mirror lakes flashing sunlight straight back into space. These are some of the weirdest things you can see from space. In the middle of the Sahara Desert, satellites once caught sight of something meant to scare visitors from outer space. It's a colossal skull staring right up at the sky. Its hollow eye sockets, long nose ridge, and cracked outline looked eerily human, almost as if something enormous had been fossilized beneath the sand. The photo spread quickly online, with people wondering if it could be the remains of an ancient giant, a lost monument, or even evidence of a civilization swallowed by the desert ages ago. But in this case, the truth is climactic. The skull is no fossil or ruin. It's the remains of an ancient volcanic pit carved out by a massive eruption hundreds of thousands of years ago. Over time, relentless desert winds carved away the softer layers of rock, while the tougher ones held firm, leaving behind ridges, pits, and hollows. When sunlight hits it just right, those shadows fall perfectly into place, completing the illusion of a face. Down in the Namib Desert, there's an incredible natural wonder. Fairy circles, roughly circular bare patches in the grasslands. From above, it looks like a perfect circle cut into the sandy landscape, surrounded by shimmering golden dunes. Some people thought it might be an ancient crater, or even a ritual site hidden by shifting sands. Others guessed it could be the mark of a long-extinct lake, or a meteorite that fell millions of years ago. But the real explanation might be even more fascinating. The formation lies in a region famous for fairy circles, thousands of mysterious round patches scattered across Namibia. For decades, no one knew what caused them. Then, researchers discovered the patterns seemed to emerge naturally, shaped by wind, roots, and even termite colonies competing for scarce water. Over time, these small circles can merge into larger perfect rings, like the one satellites now call the heart of the desert. The desert is a sight to behold on the ground, but from space, the sheer size of it will make you pause. In the heart of the Canadian Badlands, satellites can see a formation that strikingly resembles a human face, seemingly resting sideways in the soil. This quirky landmark is called the Badlands Guardian by locals. The coincidence is also great. Imagine if you could see a guy wearing a Roman helmet while looking at Italy from space. The contours create what appears to be a forehead, an eye, a nose, and even lips. Some folks amusingly insist that they can see a pair of headphones resting in the ear. For years, people speculated about its origin, pondering whether it was an ancient artifact or a colossal sculpture hidden beneath the surface. However, unless we are proven otherwise, we must believe that the Guardian is actually a natural formation, shaped by the relentless forces of wind and rain over millennia. But the headphones are real. Okay, that's a joke. They're simply a road and an oil well pad constructed long after nature had woven this artwork. Now, what makes this illusion even cooler is the play of sunlight. Depending on the angle, shadows play around in the gullies and ridges, making the face look almost real. It's an amazing natural effect, a mix of light and erosion. You could say it's our brain's knack for seeing faces everywhere. But come on, just look at it. Near Egypt's Red Sea coast, satellites once revealed something that looked almost too perfect to be natural. A massive spiral design carved into the desert floor. Thousands of sand mounds and depressions arranged in hypnotic precision, stretching wider than a city block. Well, let's speculate. It could be something left after visitors from other planets, or maybe a forgotten symbol from an ancient civilization. Now, theories spread fast. Some said it might be a secret military installation or a message meant for the skies. Others wondered if it was another one of those unexplained desert geoglyphs, like the Nazca lines in Peru. But when artists came forward, the mystery got solved. It's a bit anticlimactic. The spirals turned out to be part of Desert Breath, a massive art installation built back in 1997 by 3 artists who wanted to make something that could only be fully seen from above. Over 1 million square feet of sand were sculpted into smooth cones and hollows, designed to slowly fade away over time as wind reclaimed the land. Ironically, that's exactly why it still fools people today. From orbit, the desert's light and shadows preserve its shape perfectly, making it look brand new every time the sun hits it. It's one of those rare creations where art, time, and nature work together. The pattern is still mesmerizing, and if visitors came from above, they'd be sure to admire it, baffled as we were. Meanwhile, far out on the coastal plains of Peru, satellites revealed something absolutely unbelievable. Etched into the desert are enormous figures. From the ground, you can't see them properly, but from above, they turn into another large-scale art. There's a hummingbird, a monkey, and probably the most famous of them all, a spider. The 8-legged creature is so perfectly drawn, it looks like it's crawling across the earth. The spider alone spans about 150 feet from leg to leg, and what's strange is that it matches a species found deep in the Amazon rainforest hundreds of miles away. So, how could people 2,000 years ago know what it looked like so clearly and carve it into the ground with that kind of precision? Well, theories flooded in. Some claimed the lines were messages to deities watching from the heavens. Others thought they might mark the paths of underground waters or serve as ritual sites to call for rain. But the leading explanation today is both clever and beautiful. The Nazca people scraped away the dark gravel coating the desert to expose lighter soil beneath, creating enormous white outlines that have survived for centuries thanks to the desert's dry, windless climate. The Nazca lines were never meant to be seen from the ground, at least not by wingless humans, but now we have satellites and it's breathtaking. Now, over in China's Gobi Desert, satellites once captured a series of bizarre geometric patterns etched into the sand. Huge grids, bright white lines, and crosshatching that go on for miles. When they first popped up on Google Earth, they went viral. People thought they were looking at gigantic runways, coded symbols, or even the remnants of a lost civilization. Some even speculated they might be a message meant for visitors from space. Well, eventually, experts figured out that those massive lines were actually satellite calibration targets used by China to check the accuracy of their military and remote sensing satellites. Those bright white patterns reflect sunlight really well, helping instruments measure distance, focus, and orientation from way up in orbit. The shapes are really large. Some are over a mile wide and set up in perfect right angles that would impress any perfectionist. They're made for cameras thousands of miles above, not for human eyes. From the ground, they just look like stretches of gravel and stone, but from space, they turn into some of the most precise targets ever created by people. There's more, but that's for some other video. For example, the Eye of the Sahara in Mauritania, a massive 25-mile wide spiral that looks like a portal burned into the desert. Or the boiling Danakil Depression in Ethiopia, glowing in neon golds and greens like it's from another planet entirely. It's kind of cool that you can observe works of art just by zooming in a bit, like it's all just a matter of perspective. Okay, see that tiny dot in the dark sky? Squint. Still nothing? No wonder. Even though it's very close to Earth in cosmic terms, it's still 18 light-years away from us. But one day, this distant world you can't see with the unaided eye might become a new home to us, because it likely has all the right stuff for life. They're calling it GJ251c, and it's a super-Earth. Now, a quick side note. Super-Earth sounds epic, but it doesn't mean it's some fancy version of Earth with superpowers. It just means it's bigger, somewhere between Earth and the gas giants like Neptune. These planets can be rocky, gassy, like me, or a mix of both. The super only refers to size, not whether you could actually spend your vacay there. Now, this planet sits perfectly in what scientists call the Goldilocks zone. It's not too hot, not too cold, just right for liquid water to hang around. And where there's water, there could be life. We're talking about at least some weird bacteria with serious survival skills. Of course, scientists are still trying to crack the code of what actually makes a planet come alive. There's a whole mix of conditions: distance from the star, atmosphere, and temperature. And GJ251c looks like a top contender. The first thing astronomers check when they stumble across a new super-Earth is if it's rocky like Earth or just another ball of gas like Neptune. Because so far, Earth's still the only rocky world we know that actually supports life. And second, could liquid water exist there? Because water is the ultimate life ingredient. Finding a planet that checks both boxes is super rare. Out of the thousands of exoplanets discovered so far, only a tiny handful hit that sweet spot. So when astronomers realized GJ251c might be one of those, and that is just 18 light-years away, well, they got pretty hyped. The planet star GJ251 is a red dwarf, a small, cool star about 1/3 the size of our Sun. Because red dwarfs don't put out as much heat, their Goldilocks zones are close in, which actually makes planets easier to find. They whip around faster, so scientists can pick up their orbital patterns more easily. Scientists have been keeping an eye on this star for a while, having collected over 2 decades of data. They already knew it hosted one planet, GJ251b, another super-Earth that orbits every 14 days. But sadly, it's way too close to the star to be habitable. But then, digging deeper into the data, the team spotted hints of another world. It was GJ251c. This one looked promising. So astronomers started watching how the star itself wobbled slightly. Those tiny shakes happen when planets tug on their stars with gravity. The bigger the planet, the harder it pulls. Unexpectedly, the researchers didn't just see the signal from the known planet, GJ251b, there was another tug. GJ251c circled its star every 53.6 days. Now, the catch is, we still don't know much about this new world. We got its mass, sure, about 3.8 times heavier than Earth, but since it doesn't cross in front of its star, we can't tell how big it is or what it's made of, yet. Basically, we found its gravitational footprint, but not the planet itself. Still, astronomers are excited. The new world is bright, close, and perfectly placed for future missions to actually see it directly. That's like going from hearing a noise in another room to opening the door and seeing what's making it. Now, at the same time, that kind of direct imaging is incredibly hard. Stars are bright and planets are tiny faint specks right next to them. But the new generation of telescopes, the big ones being built right now, might finally have the tech to pull it off. For now, the team's being cautious. The discovery looks solid, but they want to confirm it with even sharper instruments. The next step might literally be seeing this world with our own eyes, well, through a billion-dollar telescope. But for now, it's a really promising mystery world. It's just a matter of looking closer. But let me tell you another thing, and I bet you didn't expect anything like this. Even if another civilization existed on GJ251c or some super-Earth, they might be totally stuck at home. A new study suggests that for all their fancy tech, they'd have a seriously tough time getting off the ground. And I mean it literally. The problem? Gravity. It's a total spoil sport. The thing is, super-Earths are way bigger and heavier than our planet. As a result, their gravity pulls a lot harder. And when gravity cranks up, so does the fuel bill. It skyrockets, pun intended. Launching a rocket from one of those worlds would take exponentially more fuel than it does here on Earth. On a planet that's about twice Earth's radius, the mass can jump to roughly 10 times that of our home planet. That means gravity could be more than twice as strong as what we feel on Earth. Think weighing 300 pounds instead of 150, just by standing there. Ew. Now, this extra gravity isn't all bad. It helps keep a thicker atmosphere, which means better protection from cosmic rays and radiation. That's great news if you're a microbe trying to evolve without getting zapped every few minutes. The thicker air could also help regulate temperature and even support more complex weather systems. So, for life starting out, that's a big thumbs up. But when it comes to building rockets, it's a total nightmare. That same gravity that holds the atmosphere also chains you down. For example, let's take Kepler 20b, a super-Earth about 1.87 times Earth's radius and 9.7 times its mass. There, a chemical rocket trying to launch just 1 ton, which is about the weight of a small car, would have to be 3 times the size of the Saturn V, and that's the biggest rocket ever built, which carried about 45 tons to the moon. Even if our hypothetical super-Earth inhabitants were smart enough to dream of space travel, they'd quickly run into a gravity-sized problem. Sure, they might try to build launch pads high up in the mountains to shave off some of the crushing gravity. But on big planets, mountains don't get tall. The immense gravity just squashes them down before they can grow sky-high. Oh, by the way, that's why the tallest peaks in our solar system aren't on the big planets at all. Mars, which is quite a lightweight world, hosts Olympus Mons, a volcano that towers 13.5 miles high. But on a much heavier planet, mountains that tall would collapse under their own bulk before the rocket builders even got halfway up. So our poor super-Earth engineers would probably need to build massive artificial launch towers just to get closer to thinner air. If they had flight technology, like airplanes or helicopters, they might try flying their rockets up first and then lighting the engines in midair. We're actually inching towards something like that on Earth with air-launched rockets. But what if that planet was a water world, and a lot of super-Earths might be? In that case, their smartest species might not even live on land. They easily could be aquatic geniuses. Picture dolphin-like engineers or squid astronomers forced to launch rockets from underwater. Kind of ballistic missile submarine-type space launches. But even with all that effort, the physics is still tough. For a super-Earth about 10 times Earth's mass, chemical rockets could technically work, but the cost would be ridiculous. You'd need so much fuel that you'd have to burn through a sizable fraction of the planet just to get one ship into orbit. The only real options for super-Earth civilizations might be nuclear-powered rockets or space elevators made of materials stronger than anything we've discovered. Until then, those creatures might stay stuck on the ground with no satellites, no space stations, and no super-Earth NASA. So, as our telescopes keep spotting new, potentially habitable worlds, we probably shouldn't expect to find any weather satellites circling above them. If there's life out there on the super-Earth, it's likely gazing up at the stars, wishing it could visit them, just like we once did.
We've all thought about rewinding time, whether to fix that cringeworthy mistake or a sneak peek at next week's sports scores. But let's be real, those thoughts fade. For most of us, time travel is just a fun movie idea. But for astrophysicists, time travel isn't just sci-fi. It's a serious puzzle hidden in the fabric of space-time. And now, new models suggest the universe might just allow time to bend in ways that didn't seem possible. Humans were intrigued with manipulating time long before complex scientific models. In an ancient Hindu story, a king visits the heavens for minutes and returns centuries later. In a Japanese legend, a fisherman spends days in an underwater palace and comes back to find generations have passed. These are some of the myths that hint that time doesn't flow the same everywhere. And time traveling as a concept didn't just pop up from regret or curiosity, it also came from watching space. Time feels like one constant in our lives. It's always moving forward like a river. It flows forward and it's predictable. But when we zoom out, way outside of our planet, it's a different story. To physicists, time bends, stretches, and slows down depending on how fast you move or how strong the pull of gravity is. And that's not just a theory, it's measurable, proven, and built into the technology we use every day. For example, astronauts on the ISS orbit Earth at 17,000 miles per hour. And their clocks tick just a tiny bit more slowly than ours. It's only milliseconds, but technically, they've aged less. You can see this effect in your everyday GPS as well. Satellites up there feel less gravity, so their clocks tick a bit faster. Imagine playing a racing game where your car and your controller are a bit out of sync. That's why GPS needs constant tweaks, or else your phone would think you are miles away. Gravity also messes with time. Scientists proved it using 2 atomic clocks. Atomic clocks are like the ultimate devices that measure time. They don't tick with gears or crystals. They tick with atoms, the universe's own metronomes. One clock was on a skyscraper roof, the other closer to the ground. The lower one, feeling stronger gravity, ticked just a tad more slowly. The difference was tiny, but it proved that even height can tweak time. Now picture being near a black hole where minutes could equal years elsewhere. This might help you get those mind-bending scenes from Interstellar. So yes, time bends, and scientists know this. And the challenge now is learning how to do it on purpose. Einstein's work proved that time could move differently for different observers. The faster you move, the more slowly time passes for you. This phenomenon is called time dilation. Think of Marvel's comic Flash. He runs incredibly fast, but he doesn't really slow the world down. His own clock runs more slowly, so to him, everything else looks frozen. If you could reach the speed of light, your time would almost stop entirely, while the rest of the universe would keep racing ahead. For decades, physicists believed that was the only path to real time travel. But the Flash is a superhero, and Einstein proved that nothing with mass could reach that speed. The faster you go, the heavier you become, and the more energy it takes to keep accelerating. To actually reach light speed, you'd need infinite energy, because your mass would become infinite too. Since infinite energy doesn't exist in the universe, it's physically impossible. That's why physicists started asking questions like, if time can stretch and bend, could it also fold? In 1994, physicist Miguel Alcubierre posed a question. Could Einstein's math let us travel faster than light, not by breaking the rules, but by bending space itself? His answer was, maybe. He imagined a warp bubble, a region of space surrounding the ship that moves with it, carrying it along like a cosmic conveyor belt. In this bubble, the spaceship itself doesn't move. The space in front shrinks, the space behind stretches, and the ship rides the wave forward like a surfer gliding on a moving sea. Inside the bubble, the ship feels no motion. It's sitting still, but the bubble carries it across huge distances. And because the ship isn't moving through space faster than light, it doesn't break Einstein's rules. The universe itself does the moving. That hypothetical bubble would need a special kind of energy to bend space-time this way. Originally, Alcubierre's equations required negative energy or exotic matter, a substance that's never been found in usable amounts. Early estimates said we'd need more energy than Jupiter could provide. For years, scientists have wondered if the universe could allow something like a cosmic shortcut without breaking the known rules of physics. While nothing practical has been found yet, theorists have explored models that closed time-like curves, loops in spacetime that bend back on themselves. Here's how it works. Imagine spacetime as a giant sheet. Normally, moving across it takes time, like walking across a field. But a closed time-like curve is like drawing a circle on that sheet. If you walk along it, you could eventually end up back where you started. In spacetime terms, the start and end could be different moments in time. So instead of just moving through space, you're following a path that loops through time, a theoretical shortcut to the past. This isn't pressing a button to hang out with your younger self, it's more like a time detour, a loop in the universe that could let something trace its way back to the past, all without breaking the speed of light. Einstein's math already lets spacetime do gymnastics near spinning black holes, twisting like a cosmic corkscrew. Physicists can explore these loops on paper, but creating one in a lab is far beyond our reach. If one day we could turn this math into a real spaceship, a warp bubble wouldn't actually make the ship go faster than light. Well, technically, there would be no speed. Inside the bubble, the ship wouldn't move at all. Instead, it would fold space like a piece of paper, bringing two faraway points together. The ship could get there in minutes while still obeying the cosmic rules. This is how it worked in the famous Star Trek series, and what many movies adopted as a method for space travel. In a hypothetical situation, a warp bubble wouldn't just be for spaceships. You could send a probe, a package, or even a cup of coffee across the galaxy without it actually moving through space. It's pretty cool, because since the bubbles move space around it, everything inside stays totally still relative to the bubble, which means no spills and no weird forces acting on the coffee. However, we are still far away from that point. The challenges we face are pretty massive. We still don't have enough energy, and folding space-time at will is still out of our reach. But for the first time, the math suggests that it's not impossible. What used to seem like pure sci-fi is now popping up in real science journals. These concepts aren't just about whipping up time machines or warp drives. Even if we never pull off a warp drive, figuring out how space-time works is a big deal for understanding reality. For now, it's all theory and simulations, but every experiment pushes the impossible line a little further. Yesterday it was no, today it's maybe. And in science, maybe is where the most exciting things happen. So while we're not ready to build time machines or bubbles across galaxies yet, scientists can now study and test these ideas using real physics, which will lead to new exciting discoveries. That is, unless future Earthlings figure out how to do it maybe 1,000 years from now, so they travel back in time to show us how we can do it ourselves. Which will create a grandfather paradox, unless someone sends the idea back in time and